For this piecewise defined function, we start by conducting a continuity test at x equals -2. To begin our continuity test, we take -2 and we plug it into the function. For this piecewise defined function, we will plug into the first piece because that is where x is less than or equal to -2. So -2 goes into the first piece for x. We have -2 plus 1. We get -1 back. Next, we look at the limit as x approaches -2 as it's applied to this function. To do that, we must explore the left-hand limit and the right-hand limit. For the left-hand limit, the piece we're going to play with here in this piecewise defined function is going to be x plus 1. The reason is because that piece is defined where x is less than or equal to -2. If it's less than -2, it's to the left of -2. For our right-hand limit, the piece we're going to play with is x squared minus 5. The reason for that is if we're approaching -2 from the right, we're talking about values of x that would be greater than -2. At this point, we take -2 for our left-hand limit and we plug in for x. -2 plus 1 gives us -1 back. For our right-hand limit, we take -2 and we plug in for x. We have -2 squared, which is 4, minus 5, which is -1. We find we get the same values back for both the left-hand and right-hand limits, meaning our limit as x approaches -2 applied to this function is that value we got back for both of -1. Since this value here matches this value here, we conclude that this function is continuous at this value of x being -2 because the limit as x approaches -2 applied to this function is equal to the value we got back when we took -2 and we plugged into the function. So it's equal to f of -2. Now, in the same manner, we will conduct a continuity test at x equals 1. We begin by taking 1 and plugging into the function. We will plug 1 into the second piece because that is where x is less than or equal to 1. So 1 goes into the second piece for x. We have 1 squared 1 minus 5, which is -4. Next, take your limit as x approaches 1 applied to this function. Just like we did with our other continuity test, we have to take the limit as x approaches 1 from the left. We have to take the limit as x approaches 1 from the right. Now we need to sync up our pieces for the left-hand and right-hand limits. For the left-hand limit, we will use x squared minus 5. The reason we use x squared minus 5 is because x is less than or equal to 1, so we're to the left of 1 there. For our right-hand limit, we will use this last piece, 5 minus 3x. The reason we use that piece is because we're talking about values of x that are greater than 1. Those would be values that are to the right of 1. Now we plug in for each of these limits. We plug in 1. We get 1 squared here minus 5, so -4. For the right-hand limit, we plug in 1. If I plug in 1 for x, I have 5 minus 3 times 1. That'd be 5 minus 3, or 2. Notice we got different values back for the left and right-hand limits. That means our limit as x approaches 1 applied to this function does not exist. That means the function is discontinuous at x equals 1 because the limit as x approaches 1 applied to this function does not exist.